Greetings! I had a problem, and I had a problem because I was looking for a problem and I couldn't find the right problem for my purpose. So my problem was not having a problem. So when I was looking for the problem, I found a problem, a relatively simple problem, and therefore I got rid of my problem of not having a problem. Does that make any sense? And here is what I mean. So what I meant before by a problem, I was looking for an excuse to just make a simple PCB and make something moderately useful. So you may want to know what is the status of certain pins or certain lines on your breadboard, because you've got something connected to it and you want to see if it's working. At first glance, it seems like there's nothing simpler to solve. I've got a resistor going into an LED, LED to ground, and if the pin is high, LED blinks, as you can see in this example. Yeah, the green LED blinks in line with the LED on the board, which seems to be working. But I don't quite like that because A, you cannot connect the LED directly from the pin to the power rail because you need a series resistor. So you need to connect the LED somewhere else, fan out the resistor. It's taking too much space. It's making everything that you are doing on the breadboard a little bit more messy, complicated, and yeah, when you're doing something moderately complex and you want to monitor, say, 8 lines or so, yeah, it's just not going to be very pretty. You're just gonna have a rat's nest of resistors, wires, LEDs and cables. How can we make it better? So here we go. I've made it a little bit better. So I've wrapped up the resistor leg around the LED anode, and I've eliminated one connection point on the breadboard, so now it connects directly to the two. Perfect. So now I can look at this and see when the LED is on, that means that the D13 output is high, and when it's off, that means it's low, right? So have a look now. Now this is very simple, but imagine I've got a lot of stuff on this breadboard, and now this is not blinking, but it should. And the problem is, I've got a bad connection over here, and all it takes is to wiggle this in to get it to blink again. But when you've got a lot of the stuff on the board, this may not be as obvious, and it's just wasted time looking at the breadboard, touching everything and seeing if you've got a dodgy connection somewhere. So I don't like this solution either. So here is the circuit that I've come up with. And it's really basic. It's based on 2 transistors. There is 4 resistors, 2 LEDs, 2 diodes and 2 connectors. And that's all there is to it. This circuit is being very simple, but it's also a little bit naughty because there is a couple of things wrong with it, but that's intentional. The way this works, this will be plugged into the breadboard, either this one or this one, to the line on the breadboard which we want to test and see whether it's high or low. And the transistor will there is one NPN transistor switching on this diode and one PNP switching on this one. Now the naughty thing about this circuit is that if you follow the path, so this is meant to be the positive, so if you follow the path from positive, here is a diode that's forward biased, so that's okay, then resistor, then emitter base junction forward biased, that's okay, resistor, another diode, jumper here, another diode, forward biased, resistor, base emitter forward biased, resistor, and a LED forward biased to the negative. So technically this circuit should not work, i.e. both LEDs should be switched on at any given time, and they will be if you remove those 2 diodes. Now what those diodes are doing actually, it's a little bit interesting because they don't serve as, letting the current through one way or the other, because they are forward biased anyways from the power supply here on the from the connector. Transistors, most often you will have the load connected to the collector, but in this case I've connected it to the emitter for the same reason as I've put those 2 diodes in. And what this does is really interesting, because actually if you remove those 2 diodes, both LEDs will glow, will stay on, switched on at most of the time. But because every diode and every PN junction has got a voltage drop, so we have a LED over here, let's call it 2 volts, then a resistor, we can ignore that, then emitter base junction, that will be plus 0.7 of a volt, then this diode 0.7, then this one plus 0.7, base emitter another plus 0.7, and another LED. Let's call it another 2 volts. When we add all of those up, that's 2.8, that's 6.8 volts altogether. And that will be more than the power supply over here, therefore those LEDs will not switch on. Now what I found, without those diodes they do actually glow and stay on, so adding those diodes increase the forward voltage drop of all the silicon in the circuit and prevents it from coming on. Now this circuit I've tested, it works fine with 5 volt circuits and 3.3 volt circuits. Here it is. I've put it together on a breadboard and it's still connected to the same blink sketch, just blinking an LED on pin 13. This works right now off of 3.3 volt over here, but I can move it over to 5 volt and it will be just as fine. A little bit brighter, but it's fully visible on both voltages, and I think that's most of the stuff that I'll be working with on a breadboard. And here's the 2 transistors, a few jumpers, 4 resistors, 2 diodes, and this is just a jumper link going over to the pin D13 where the LED is blinking. There is a small restriction in how this can be built, because I want all of those, each circuit like this. I'm going to build 8 of those, just because 8 bits is a round number, twice as round as 0. The spacing between those pins is not much, and if I want to plug those in like cards, I need to make sure that I fit the PCB with all the components in between the pin headers, in between the holes. So that would be a little bit challenging. It wouldn't be if I was using surface mount components, but I will be using those. I will be using through hole parts, and I will be aiming to get this in between the boards so I can plug it in any way I want. Here is the PCB I designed for this. This is 3:1 ratio, so it's 3 times as big, and this is 1:1 ratio. So here is a pencil for comparison. It's really small. It shouldn't obscure anything on the breadboard, and I should be able to just plug it in on the edge wherever I want. It's worth mentioning this video will also be a test for a new marker pen, also Lumocolor from Staedtler, but this is the permanent special fine point 0.6 of a millimeter, and those special ones are available in red and black, and those offer apparently much better adhesion to many surfaces. Before I tried this one and the results weren't great, but later on I did another test using this pen and using this pen, a really small one. Here it is. I didn't have any lifting of the board, so I tested both of them. This side is done with the red one and this one with the blue one. The red one had a little bit finer point. Both are 0.06 millimeter, but yeah, the red one seemed to be doing a little bit better, so I will be using red one. Previously when I did it, I reused the board that was partially etched, and that's probably what was part of the reason for failure. And here is the board loaded into the pantograph, and I've panelized over here 8 of those PCBs. So let's give it a go. I will be using a ruler this time to prevent any shaky lines, and I'll see how that goes. Now I won't be recording video. I'll try this time. I've tried it once and I quite liked it. Time-lapse video or time-lapse shooting, so the camcorder will be just shooting still pictures, and I'll see how that works out. Here is the mini panel painted, I guess, with the marker, and as you can see, some shiny lines there. I did make a few shots which I had to scratch off, but not a biggie. The question is, how will it hold up to this special type of marker? Let's get the Seno box and let's pop it in and see. I've pre-warmed the Seno solution in just hot tap water as usual. Makes it work a lot faster. Okay. Someone in the comments in one of my previous videos suggested to put a light underneath. So if I just get one of my power banks And yeah, we'll be able to see once the copper gets etched out, we'll be able to see. Okay, a few more minutes in, about 10 minutes or so, and you can see the trucks are starting to show up. So far so good. I don't see the marker coming off, so it's holding kinda well. Okay, and I think this is done. At least it looks it. Yeah, it looks rather good. I think this marker is really good. It seems like all the trucks have stayed where they were supposed to. There we go. That turns out quite okay. Okay, so far so good. A little bit acetone. And let's see what's under the marker. And well, it looks alright. I have center punched all the pads where the holes need to go. So now I'm going to drill them. And here is the PCB all drilled out, and the last machining parts of this, make sure it fits in between the pins on the breadboard. So what I'm going to do in order to overcome the thickness of everything, I'm going to mill out pockets like this. I did a few depth tests over here on the side, so I'm just going to be using a little boring head, and I will mill out pockets for all the resistors and the transistors like I marked here on the back roughly with a pencil. After I solder this stuff in, the thickness should be just barely more than the thickness of the PCB itself. And there it is. Turned out okay. I should have been more careful actually, because I did went through, I misjudged the depth a couple of times, but it's fine. A few trucks are damaged lightly, but this doesn't matter, it's still usable. I'll just lay a resistor leg over where the damage happened. You see, the resistors will fit into the little pockets and they barely stand out from the PCB, but the transistors, the TO92 package is much too thick, so I need to grind this down to make it a lot smaller. So here's a bag of transistors. I've got the 2N3906 and 2N3904. I got those from eBay, from Bright Components, really cool shop. What I need to do is grind it down so it's very flat. Right, so here is the transistor after. Let's see if I've not damaged anything, because there's a risk that if I go too far I can damage the bond wires, but this should be okay. Yay! Still a transistor. Much thinner though. So now I just need to do it, how many? 15 more times, and I'll have the set of 16 transistors. And time to solder this, so I think I'll begin with diodes. And I'll put those in here. There's one here, one here. They're all just 1N4147. I just need to pay attention with one board and then just copy the layout onto the others. Yeah, it's not sticking out too much. So far so good, not much more than a PCB's thickness. And here is the first couple finished, completed, kind of, or fully assembled. And they're blinking here. I've got yeah, 6 more to complete. It's still not thin enough to fit into side-by-side holes. I'm borderline there. I think I'll need to grind this down a little bit afterwards and see if I can get to it. And I am about done. So I can plug those in over here. This way. And it's blinking. There it is, finished-ish. So this is what it looks like. It looks absolutely horrible. My intentions were to actually paint the entire thing with maybe like nail polish lacquer or something along those lines to keep it somewhat nicer. But if I'm going to do that, I'll do that later off camera. But in essence, well, it works as an indicator, works quite nice. So it shows this at the moment, they're all connected to the same pin, but it shows whether the pin is high or low, or if there is just no signal, high impedance, whatever that is. Yeah, it just goes, it switches off, so it doesn't show anything. And as soon as it receives high or low, it will light up the relevant LED. I'm quite happy with that. The only thing I'm not happy with, here it is, there's 3 of them bunched up together, and yeah, not very good, a little bit too tight. So yeah, if I used surface mount components and drilled pockets for them, I think that would have worked, because those resistors, if I couldn't drill any deeper, make the pockets any deeper, because I was already poking holes through it on some of the boards. So yeah, work in progress. This works as a proof of concept, but I'll probably revisit this at some point with some smaller parts and try to make it a little bit smaller. But I quite like this as an indicator. It's yeah, it does work quite well. So hope you enjoyed this video. Please do give me a like if you did, and please do subscribe for more random electronics related stuff. For this one, that's it. So take care.